Okay, Krishna, let's get started without any further ado. I guess the others aren't available today. But anyhow, since you have joined, we still will be speaking the session. So, first of all, did you join the session yesterday, Krishna? Were you there for the session yesterday?
Okay.
Oh, you weren't there for the session yesterday. Okay, cool. No problem then. Again, in order for you to understand what we're going to talk about today, you would have been there for the class yesterday, but no problem. We'll take it from the very top again, from the very beginning again. So I'll just give you an introduction to what we learned in the class yesterday. We were talking about basic networking fundamentals. So whenever you talk about networking, Krishna, there are two important definitions to know. Firstly, what is a host and what is a network? Now, when you talk about a host is any information device which is capable of communicating with other devices, which is capable of sending data or receiving data from other devices. So in our home network, if we have a Wi-Fi router, to that Wi-Fi router, we connect multiple devices. We connect our phones, we connect our laptops, we might connect our smartwatches, whatever it is. All of these devices which are connected, okay, to each other, each of it is called as an individual host, okay, an information system. Now, when these devices are collectively talking to one another, there's a group of these devices, that group is called as a network. Now, when we humans communicate with one another, we have our names to address each other. I can call you as Krishna, you can call me by my name as Shoaib. Similarly, these devices also have names. That name is called as an IP address, where IP stands for Internet Protocol. This was developed by the US military in the late 1950s or 1960s. Okay, and again, there was IP version 1, IP version 2, IP version 3. They were not so successful. What properly worked out, or what is still being used in today's world, is IP version 4. Okay, IPv4 it is in short. Okay, so you don't have IPv1, IPv2, IPv3. They are failures. What was a successful attempt was IPv4. Okay, and we're still using IPv4 in today's world. So this IPv4 address has a few properties to it. Okay, firstly, it's a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros and ones. A bit is the smallest data format. Okay, the smallest data size is called as a bit. It either contains the value of 0 or the value of 1. Okay, and your IPv4 address is a 32-bit address. It contains 32 zeros and ones consecutively. And these 32 bits are equally divided into 4 parts of 8 bits each. So here you have 8 bits, then there's a dot, after that then another 8 bits, and then the dot, and another 8 bits, and then the dot, and then the final 8 bits. In total, 32. Okay, and each of these portions of 8 bits is called as a byte. Okay, so when you have 8 bits, it becomes a byte, or it can also be called as an octet. Octet in the sense 8. Okay, and each octet or each byte is separated or divided by a dot symbol. Okay. So this is what your typical IPv4 address looks like. Okay. Now this language of zeros and ones is called as binary language. Computers always communicate with one another in the binary language, in the language of zeros and ones. But we humans don't understand binary so easily. What we regularly use in our day-to-day life is decimal language, numbers from 0 to 9. So in today's class, I'm going to show you how we can convert any computer readable language, computer understandable binary language, to a human readable decimal number, okay, or a decimal language. Okay. Any questions or doubts up to this part, Krishna? What is an IP address, or what is this address?
No.
Perfect. Now, before we get into the conversion of binary to decimal, let's again do a quick recap on data sizes. So 1 bit is equal to 0 or 1. When you combine 8 such bits, that becomes your byte. It can also be called as an octet. When you combine 1024 bytes, approximately or closely enough to 1000 bytes, that becomes a kilobyte. Okay, this TextPad file is in kilobytes of storage. 1024 kilobytes becomes a megabyte. 1024 megabytes becomes a gigabyte. 1024 gigabytes becomes a terabyte. Okay, and 1024 terabyte becomes a pentabyte. We, on our systems, on our hard drive storage, we usually use terabytes of storage. Okay, pentabytes are used by cloud organizations. Okay, Amazon Web Services clouds, or again Google Cloud, OneDrive, Dropbox, all these cloud services which have storage of millions of users of data. Okay, they use petabytes of storage. Okay, now coming back to the conversion, how do you convert a binary number to a human readable decimal? So over here, I have taken this number, the first octet 10101010, and now we'll learn how can we convert this binary number to a human readable decimal number. So there are two simple rules to convert any binary number to a decimal number. Rule number one is you have to write down the values from 2 power 0 to 2 to the power 7 from right to left under each bit. So here, this is the first bit on right side. Under that, I have written 2 power 0. Next, second bit, 2 power 1. Third, 2 power 2. Then 2 power 3. Then 2 power 4, 2 power 5, 2 power 6, and 2 power 7. So under each bit from right to left, you write down the values from 2 power 0 to 2 to the power 7. Okay. And again, what are the values for these numbers? 2 power 0. Anything to the power 0 is always equal to 1. It's a mathematical rule. 2 power 1 is 2 itself. 2 power 2. 2 power 2 is 2 into 2. That's 4. 2 power 3 is 2 into 2 into 2. 3 times. That's 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Okay. So now, once you have written down those values, all you have to do is multiply each number, each bottom number with each top number, and just keep on adding with the next one. So 2 power 0 into 0. So how much is that? 2 power 0 into 0, that's 0. 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, the value is 2 itself. 2 power 2 into 0, that's 0 again. 2 power 3 into 1, 2 power 3 is 8. So 8 into 1, that's 8 again. 2 power 4 into 0, that's 0 again. 2 power 5 into 1, that's 32. And 2 power 6 into 0, that's 0 again. And finally 2 power 7 into 1, that's 128. When you add all this up, 128 plus 32, that's 160. 160 plus 8, that's 168. 168 plus 2, that's 170. So when a computer reads the number as 10101010, the human or decimal equivalent of it is 170. So when we are typing 170 on the screen, the computer reads it as, vice versa, it reads it as 10101010. Okay. Is that clear, Krishna?
Okay.
Perfect. Now, you might have a question, why are we learning this decimal to binary or binary to decimal conversion? The reason being, we are learning this to understand the range of IP addresses. So if you wanted to get the first IP, the only possibility is to put all zeros everywhere. Okay. So when you put all zeros and when you convert that from binary to decimal, you get the number 0.0.0.0. That's the first IP address. And if you want to get the last IP, all you have to do is put all ones everywhere in each octet. And when you put all ones everywhere, what is the conversion for that? 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 plus 2 power 4 into 1, all the way up to 2 power 7 into 1. So that would give you 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And when you add all that number, all those numbers, you get the number 255. So the last IP is 255.255.255.255. Okay. So when you convert all ones in binary format to decimal format, you only get 255. So you will have IP addresses only ranging from number 0 to 255. You will not have any negative numbers, or you will not have numbers above 255. So it's a very important point to remember. All IP addresses will range only between number 0 to 255. Why specifically 255? Because when you convert all ones in the binary format to decimal, you only get 255, not more than that. Okay. Now, we know that this is the first IP, and we know that this is the last IP. What about the IPs in between? What is the sequence of IPs? Okay. So to understand the sequence of IPs again, there are two simple rules, Krishna. Okay. Very important to remember. Rule number one, always start with the rightmost value. So what I mean by that is, if this is the first IP, 0000, the next IP is going to be 0001. The rightmost value will increase by 1. Okay. So after 1, 0002, then 0003, then 04, then 05, then 06, then 07, 8, 9, 10, goes all the way up to 0254 and then 0255. Now once it reaches the maximum value here, 255, what happens after that? Now comes rule number 2. Only after the rightmost value has been completely filled, then we go to the left value. Okay. So this left value over here, after this left 0 becomes 1. Okay. So now once that changes to 1, the rightmost value is reset back to 0 again. So this 255 cycles back to 0 again, comes to the first value again, and the next value increases by 1. Okay, so after 0, 0, 0, 255, you have 0, 0, 1, 0. Now after 1, 0, don't directly jump to 0, 0, 2, 0. That is wrong again. Okay, remember rule number 1, always start with the rightmost value. So 1, 0 becomes 1, 1, then 1, 2, then 1, 3, then 1, 4, goes up to 1, 2, 5, 5. So if you notice over here, whatever cycle repeated here from 0, 0 to 0, 2, 5, 5, same cycle repeated again from 1, 0 to 1, 2, 5, 5. Same cycle repeats again from 2, 0 to 2, 2, 5, 5. Same cycle repeats again from 3, 0 to 3, 2, 5, 5. Yeah, 3 to 3, 2, 5, 5. Then 4, 0 to 4, 2, 5, 5. Then 5, 0 to 5, 2, 5, 5. 6, 0 to 6, 2, 5, 5. 7, 0 to 7, 2, 5, 5. Like that, it goes on and on and on. Somewhere you have 2, 4, 4, 0 to 2, 5, 4, 2, 5, 5. Then 2, 5, 5, 0 to 2, 5, 5, 2, 5, 5. Is this clear?
Yes, sir.
Right. Now, once both these octets are filled, 255, 255, this 0 now changes to 1. And they become zeros again. So 255s become zeros again. And this 0 becomes 1. Now, whatever cycle repeated from 0, 0, 0 to 0, 255, 255, same cycle repeats again from 1, 0, 0 to 1, 255, 255. Okay, so this stays 1. And then you have 0, 0, 0, 1, 0, 2, 0, 3 up to 0, 2, 5, 5. Then 1, 0, 1, 1, 1, 2, 1, 3 up to 1, 2, 5, 5. Then 2, 0 to 2, 2, 5, 5. 3, 0 to 3, 2, 5, 5. Okay, like that finally from 0, 1, 2, 5, 5, 0 to 0, 1, 2, 5, 5, 2, 5, 5. Whatever cycle repeated here from 0, 0 to 2, 5, 5, 2, 5, 5. Same cycle repeats again from 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5. Again from 2, 0, 0 to 2, 2, 5, 5, 2, 5, 5. From 3, 0, 0 to 3, 2, 5, 5, 2, 5, 5. 4, 0, 0 to 4, 2, 5, 5, 2, 5, 5. And finally from 2, 5, 5, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5. Again, once all these are filled, they become zeros again, and this 0 now changes to 1. Again, same logic. Whatever repeated from 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 2, 5, 5. Same cycle repeats again from 1, 0, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 5, 5. 2, 0, 0, 0 to 2, 2, 5, 5, 2, 5, 5, 2, 5, 5. 3, 0, 0, 0 to 3, 2, 5, 5, 2, 5, 5, 2, 5, 5. And finally, from 2, 5, 5, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 5, 5. This is the first IP, and this is the last IP. So if I were to ask you a question, how many IPs are there in total? So each octet is revolving 255 times, and you have 4 octets. So 255 into 255 into 255 into 255. And that would give you 4.3 billion IP addresses in the complete range. So from the first IP till the last IP, right now we have gone through 4.3 billion IPs, the whole cycle. Is that clear, Krishna?
Okay.
Any questions, any confusion? Do you want me to explain anything? Do not hesitate to let me know. This is your first experience with networking. So it's going to be slightly confusing. So nothing to worry about that. But if you let me know, I can clarify it and I can make it much more simpler for you. So is there anything that you want me to explain again?
No, present.
Now, this is clear. I have a question for you. Now, are these 4.3 billion IPs sufficient in today's world? That's my question.
No, sir.
Definitely not, because the population itself is around 8 billion people, and you only have 4.3 billion IPs. So even if you assign each IP to a single device, 4.3 billion IPs are still not. So that is why
Each person have 2 to 3 mobiles and the laptops.
Again, yeah, each person can have multiple devices as well. So on an average, if each person has 2 devices, you would still require 16 billion IPs. But we only have 4.3 over here. So that is why they came up with a solution called NAT, which stands for Network Address Translation. Now, in this concept of network address translation, what they did was they divided these 4.3 billion IPs into something called public IPs and private IPs. So again, there's two categories of IPs now, called public and private, where public IPs are the IPs which are unique to each user. So public IPs are the IP addresses provided by a ISP, Internet Service Provider. Okay, and this Internet Service Provider gives you the public IP to access the internet. Okay, when you want to browse the internet, when you want to visit any website, you use the public IP for that. And then there's something called as private IPs. Private IPs are the IP addresses provided locally. So in your home network, if you have a Wi-Fi router, that Wi-Fi router gives a private IP. Okay, or you can also manually give it yourself. Okay, and these private IPs are only used in the intranet. Intranet in the sense local network. So if I have to draw this out, just a second, let me show this with a diagram. So if you have a Wi-Fi router at your home, that Wi-Fi router is what you connect with the, connect to the internet with. So just a second, Krishna. Let me draw this out. Right. So let's assume this is my Wi-Fi router here, this circle. Okay. Now this circle is what you connect all your devices to. So if you have a laptop at your home, if you have a mobile phone or a smartwatch, or let's say a smart TV or whatever it is, each of these devices is connected to the Wi-Fi router. Okay. So let's assume they are connected through the wireless network, and this dotted line denotes the wireless network for you. I'm so sorry, I'm terrible with drawings. Okay, so each of these devices is connected to the Wi-Fi router wirelessly. Okay, so this becomes my router here. Okay, and these are my devices. Let's say this is my PC. Okay, this is my mobile phone. This is my smartwatch. Okay, and this is my TV or something. Okay, now each of these devices is wirelessly connected to the router, and your router also gets a cable from outside your house. Okay, so you might get your internet from a company called ISP. Again, in India we have ISPs like Airtel. Okay, and there's Hibernate. Okay, all these are the people which provide you the service of internet. Hibernate, Hathway, all these are ISPs in India. And from that ISP, you get a cable from outside. Okay, it could be an optical fiber cable. That cable is provided by this ISP. So through that optical fiber cable is what you have the public IP. So there's a public IP provided by the ISP, using which you connect to the internet. So if you want to connect to the google.com website, so if there's Google somewhere over here, let's say www.google.com. This google.com also has a certain public IP to it. Okay, so from your public IP, you connect to Google's public IP. Okay, and these devices in the internal network. So if this is your home, this main square box is your home. This is your internal network here. Okay, and this in the internal network, each device gets a private IP. So your router also gets a private IP, which is the first private IP, PR1, let's say, and your PC could get PR2. Your mobile could get PR3, private IP3. Your smartwatch could get private IP4, and your TV could get private IP5. Okay, so when you're connecting to google.com from your mobile phone, the packet first travels from the mobile phone to the router using PR3 to PR1, from private IP3 to private IP1. A router is a device which allows communication between two different networks. Okay, so it is communicating in the private network as well and the public network. So it transfers the packet from the private network PR1 to public IP, and from the public, using the public IP, it goes to the ISP, and from the ISP it connects to google.com. This is how a connection forms. So this is the private IP network, guys, your local LAN network connection, and this is the public network, the internet network. Okay, here is the intranet, 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 and this is the internet. Is that clear, Krishna? Any questions or doubts up to this part?
Okay.
Right. So again, these are the two categories of IPs that you have. So if you want to check each of these IPs for your system, all you have to do is, if you want to check the public IP first, you have to go to your browser, and in the browser, what is my IP? And with that, you can see the public IP that you're getting for your system. So if you click on this link here, what is my IP address.com, this also shows information. Yeah.
This is your system IP or public IP?
No, not the system IP. This is the IP provided to the router from the ISP. Okay, so when I'm getting a LAN, a connection from the ISP, This IP is what is given to my router. Okay. So when my system wants to communicate with the internet, the packet goes from my device to the router first, and from the router it uses this public IP to connect to the internet. Okay. So this was the IP as if you remember in the diagram. Oh, I erased the diagram here. But if you remember in the diagram actually, if you remember here, this public IP, this is the IP that we are seeing in the browser right now. The 49 dot something, 49.204.238.207. This is the public IP. This is the IP which is given to my router. If I want to check my private IP, let's say if I want to check my PC's private IP, this one. For this, I have to run the command called ipconfig. So I have to open up my command prompt. So I can go to my command prompt now. Here, drawings. Go back to Windows, search for command prompt here. Click on the first suggestion. And with that, just type ipconfig here. It stands for IP configuration. And now when you hit enter, it shows you private IP. This is my private IP. Okay. So I'll explain why specifically this IP. What is this 192.168.04? Why are we having only these numbers? We'll talk about that in the next class on Monday session. But for now, this is how you check your private IP, and this is how you check your public IP. So this is what we talked about in the class yesterday, Krishna. Again, I just elaborated a little bit more. Today we have just taken a small demo in a brief method to what are IPv4 addresses, how do you check your private IP, how do you check your public IP, how do you convert a binary number to a decimal number, and what is the range of private and the complete IPv4 addresses, and also we learned about the sequence of IP addresses. These are all the concepts we talked about. In the next class, I'm going to talk what are the different categories of public and private IPs. So there's something called classes as well, class A, B, C, D, and so we'll talk about those classes, and we'll talk about the necessity of those classes in the next session. Okay. So yeah, that's that, Krishna. Nothing for a brief introduction to networking fundamentals. Again, please make the payment to the institute if you have not already made the payment. So again, we're going to be starting the original classes, I mean the Lendia session from Monday onwards. Okay. So please do make the payment because the institute might change the link if you have not made the payment yet. Have you already made the payment, Krishna?
Oh. Sir?
Did you make the payment already?
No. Actually, they called me. I pay Monday.
Okay, Krishna, no problem. Okay. So yeah, that's it, Krishna. Nothing further for our session. A brief introduction to what networking is. We'll elaborate on this and talk a bit more in depth about networking concepts on Monday's class.
Okay.
So yeah, that's it. Have a good weekend. I'll see you on Monday again. Bye.
Okay, thank you.
Thank you, Krishna.